Hi, welcome to your third lesson on binomial distribution. This is a bonus lesson because we didn't have time to quite go over all this in class, and I would really like for you to feel more confident and prepared with this topic as we move into our next lesson. So let's pay close attention. You will continue to use the notes page that we used the last time. We will complete the remaining problems in there together. Okay, but first, a quick recap. We talked about what is called the Galton board, and we saw it in action. We saw the balls bouncing through there, and we noted that very few balls end up on either side, and most of them end up in the middle. And that's because when a ball bounces off a peg, it can bounce either left or right. And for a ball to end up on either side, it needs to bounce either left, 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 left all the way, or right, 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 right all the way. But since a bounce has an equal probability of left or right, it's very unlikely that it will bounce the same way over and over again. All right, so very interesting to see, especially when you see it actually physically happen with this machine. This is connected to Pascal's triangle, as we saw right here, where we see there's bigger numbers in the middle and only ones on the side. And as you may remember, every number in Pascal's triangle represents how many paths there are to get to that location. For example, if a ball began here and it was bouncing, 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 there would be 6 different paths it could take to get right here, and 4 different paths it could take to get right here, but only one path to bring it to this spot right here. And that would be the path where it bounces here. All right, so that's just a summary. Let's continue. We looked at that through this investigation, which is really great to see the connection between Pascal's triangle and the Galton board. And now let's investigate on a line. There's a great simulator, which I'm going to show you a couple other interesting things with. So let me find it now. Let's see, where did I put it? Here it is. Okay, so here's the simulator. It's a Galton board. I can launch one ball at a time here like this, see, and we can watch that one ball. Or we can launch many balls like this, and they just continuously flow through there. Let's watch them accumulate just for a moment. Just like the actual Galton board machine we saw when we watched the online video, this simulator, we can see most of the balls are gathering in the middle here, very few. I don't think any have made it to the ends yet. I'm waiting for that one ball to follow the path all the way to the end. Ooh, that one was close. All right. Anyway, we can see that shape emerging here, which is what is expected. Okay, pause it, reset it. Let's see. And now, here's where we can adjust the number of rows, so we can have more rows or fewer rows. All right, let's go all the way. I just want to see this. This looks kind of fun. Okay, let's go. All right, all right, all right. Yeah, we can spend 20 seconds of our life watching this. This is pretty cool. Okay, there's the balls. See, most of them are staying to the middle because they're going left, right, left, right, left, right, left, right. It's very infrequently that the ball goes left, 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 or right, 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 right. Okay, we can see the same distribution showing up here. It's going to be a bell curve shape. Pause that. Let me show you a couple more things. Okay, so I'm going to make the rows a little bit less. And here we can change the probability. Now this is key to this, because when we begin and a ball hits a peg, it can go left or right. And the chance it goes left is 50%, and the chance it goes right is 50%. And in that case, we saw what happens. All the balls end up here, very few on each end. But what if we change the probability? Watch what happens to these things as I move this. Let me make less of these first. As I slide this probability, look at it, it tips the peg. So now, for example, here, when a ball hits this peg, it's very unlikely it'll bounce this way. It's much more likely it'll bounce to the right. So we've basically rigged it, made this a biased peg, and there's more probability or more likelihood it'll bounce one way. And you can see 0.72. So it has a 0.72 chance of bouncing this way and a 0.28 chance of bouncing this way. So I'm going to make more rows, and let's see what happens now. So now the balls are more likely to bounce to the right more, so there'll be more bounces to the right. Notice what's going on here. We have the same distribution as we had before, same kind of shape, but it's like the whole thing's been slid to the right, right? The whole thing moved to the right, and now we see the shape emerging here. All right, pause that, add a few more rows, change the probability the other way. I'm going to make it really low. Look at that. 10%. Wow, most of them are going to go all the way that way. And play it up. Let's see. Wow, since I made the probability so low, right? 10% chance this way, that means 90% chance this way. Look at all these bounces now this way because there's 90% chance they'll bounce left. But we can still see the same shape emerging. Okay, this idea of probabilities is essential to understanding where we're going ahead with binomial distribution, because we're going to solve a lot of different problems where the probabilities are different numbers, and we're basically basically saying what paths and where they go and so on. So I'm going to leave this running in the background, and then let's go back to our presentation. Okay, so here we go. We talked about having a biased coin, and we're going to flip it 3 times. So this is going to be like a summary of everything we've learned here. So let's say we have a biased coin. Probability of getting heads is 1 out of 5. Probability of getting tails is 4 out of 5. So what this means is that heads are not so likely and tails are more likely. Normal coin would be 50-50, but you can see this one's biased. It's more likely you'll get tails. So here's the paths of this tree diagram representing this. So we'll make black heads, okay? So here's where you get a head, here's where you get a tail. And then on the second coin flip, you get another head, so now we have 2 heads. Or you get a tail, and now you have a tail and a head. And then if you continue this way, you get another head, so you end up with 3 heads, or you get a tail and you end up with 2 heads and a tail. So here's all the final outcomes based on these 3 flips. Black represents heads, white tails. So how many paths lead to 2 heads? Because we're going to answer the question, what's the probability of getting 2 heads? Okay, if you look at the diagram closely, you can see a 2-head path there, right here, and right here. So in total, 2 heads occur in 3 different ways. So 3 paths lead to that. And for example, let's see, 3 heads. What about 3 heads? We go head, head, head. Remember, there's only that one path, just like we saw on the Pascal's triangle. On the outer edges, we have the ones. And this is the same thing, right? We only have one path that leads to 3 heads. Or likewise, here's a path that leads to 3 tails, or 0 heads. So a path that leads to 0 heads, only one path, right? So 1, 1, and in the middle we have more. Okay, so that's how many paths we have. But let's look at now the probability of getting 2 heads. So here's the approach. Well, here's all the probabilities on there first of all. Okay, probabilities, let me get all those on there. Okay, so again, every head 1/5, 1/5, every tail 4/5. Okay, so the way to figure out the probability of getting 2 heads, we have to say, well, how many paths are there? And then multiply it by the probability along each path. So the number of paths, we already know there's 3 ways to get 2 heads. So we know there's going to be 3 paths. And then along each path, when you get 2 heads, it's like this. Head, head, tail. So it's 1/5 times 1/5 times 4/5. That will be a 2-head, 1-tail path. So as you can see here, here's 2 heads, right? 1/5 times 1/5, there's a 2, and then 4/5. So this is a path that leads to 2 heads. And any 2-head path will have those same numbers in it. It doesn't matter the order of those. It'll always be 1/5, 1/5, 4/5, or maybe 1/5, 4/5, 1/5, but that's still the same result, right? And then the number of paths, as you know, we've been talking about in the other videos, is calculated by the combination 3 choose 2. So that number, which basically in Pascal's triangle, whoa, let's go back in time. In Pascal's triangle, it's like saying it's this one here. 3 choose 2, right? Row 3, choose 2. Or this one here. Okay, so now let's go ahead again. Okay, so the number of paths is calculated using that combination. 3 coin flips, we want 2 heads. And that, using this formula, will produce a number 3. And then we can multiply that. Okay, so that will give us an answer of 0.096. So that's the approach. How many paths by the combination, and then what does each path look like? Alright, so that's the general approach, and there's a way to do this on your calculator. So we no longer have to use this formula for combinations. There's actually a shortcut in your calculator that'll do it for you. Let's take a look how to do it now. Alright, let's take a look on the calculator. There's a way to do the combination formula very quickly on the calculator. Here's how it's done. You press math, and then on top here you say PRB, which is probability, so we're going to use the arrow to go over to probability. And under probability you see right here NCR, that's your combination. I'm going to go down there, choose that for combinations, enter. It shows it like this. You need to arrow back to where it says answer, and you can type over 3 because you need to have 3, and then arrow beyond it, 3 choose 2, 3 choose 2, and this is combination. Run that, that number should be a 3. Let's check. And it gives us 3. Great. So that again is how you do a combination shortcut on your calculator, and it produces the number of paths. Okay, so let's take a look at the next thing. So here we ended with this in the last video, and we left these two questions unfinished. Let's look at B. This was a situation where you're taking a 6-question quiz and you're randomly selecting multiple choice answers, A, B, C, or D. If you're randomly selecting, you have a 1 in 4 chance of being right, which is 0.25. So first thing to note here is that this is a random variable x. That means x represents how many you will get right out of 6 questions. So either you'll get 0 right, 1, 2, 3, 4, 5, or 6 correct. So there are 6 trials, 6 questions, and then you have a 0.25 chance of getting one right. So now let's look at this. This says find the probability that that variable takes on a value of 2 or less, because this means x is less than or equal to 2. So that means what is the chance you get 2 questions right, 1 question right, or 0 questions right? Alright, so in that case, we can write it out like this, right? The probability of getting less than 2 correct is the same as saying the probability of getting 0 correct plus probability of getting 1 correct, or adding probability of getting 2 correct. And now for each of those, you could run the full formula. Alright, so here's, for this one it's that, and then for this second one it's this, and for this third one it's this. That's a lot there. And the expectation is not for you to do all that. That's a lot of calculating there. But let me just explain one of these again. So 6 questions, and here we're looking for a chance of getting 0 correct. So 6 questions, 0 correct. So that means 0.25, if you're following the tree diagram, you will not follow the 0.25 path, which is the getting a question correct. So there's 0 of those, but you will be getting every question wrong under this scenario. So 0.75, 3 in 4 chance you'll choose the wrong answer, and that happens 6 times because it's for each question, right? So wrong, 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 wrong. That's 6 of them. All right, and the second one, we're looking for probability equals that you get 1 right. So again, 6 questions, 1 right. So now 0.25, that quarter chance of getting 1 right, and 0.75, 5 wrong. And on and on. You could punch that in your calculator, but the good news is there's another calculator shortcut. So there's not only a shortcut for combinations, there's actually a shortcut for all of binomial distribution. All right, so this can all be done with just a couple presses of the calculator. Let's take a look. So how you do it is this. You press second, and then here it says vars, and above that is distribution. So I'm going to press that. Now we have all these distributions. Binomial distributions on the second page. So I'm going to use arrow up to go up to the next previous page. And there we see Binomial Pdf and Binomial Cdf. For this question, we're going to use Binomial Cdf. But actually, let's go back in time for a minute. Let's look at this one, which we solved earlier, and I'll explain what the difference between Binomial Pdf and Cdf is. This one here will require Binomial Pdf. When you're looking for a single value, like x equals 2, we use Pdf. So let's just double check that. Pdf, you'll go like this. Number of trials, 6. All right. The probability of getting 1 correct is 0.25. And our x value in this case is 2. And then I'm going to go down to paste, enter. And there, now you're going to press enter again. Done. It gives us an answer. If you look at your notes page, if you did the last video, you'll see that answer was 0.297. So it matches. All right. Now let's run a second distribution, or vars, and we're going to do the binomial CDF. And the times you use the CDF is when you have multiple probabilities, like we do in this question, where we had like the 0, 1, and 2. So CDF means cumulative. It means it will add up all the probabilities. So you're going to put in the upper value and it'll add all the ones below. Let me show you. So I'm running a CDF now. There's 6 trials on this one. The probability of getting a question right is 0.25, and we're looking for an x value of 2. So again, when you're in CDF, that 2, it means it's going to calculate probability of 2, 1, and 0. It's going to calculate that number and everything below. And that's what we want. So paste, enter, enter again, and we have this answer, 0.83. So now let's check here. When all those were added up, the answer is, 0.83. There it is, it matches. So if you did the long way, or now you have the shortcut on the calculator, you get that same answer. Let's see, I can see that I'm already near my 15-minute limit, so this will end up being a two-part video, so do not quit after this one. There will be one more video that follows, and it will explain this question and the remaining few questions in the notes page. So make sure you watch that. See you there very soon.